Hi everybody, I'm Mike Poland, the scientist in charge at the Yellowstone Volcano Observatory, and this is the monthly update for December 1st of 2021. I thought before we got into talking about what happened over the past month, we might talk about deformation at Yellowstone, and specifically uplift. And this is because we started to think that maybe there was some uplift happening at the Norris Geyser Basin area in last month's update. And that generated a lot of questions, and I thought this would be a good time to review what Yellowstone does in terms of its ups and downs, because it does both. It rises and it falls. So here's a map of the Yellowstone area. There's the caldera outlined in the dotted line, and we've got seismicity from 2021 in red here. There's about 2,600 earthquakes or so, not too far off the average for any given year so far. GPS station here on the east side of the caldera since 2003, this is the vertical deformation at that site, and you can see how in 2004 the site went up to 2009 and then went down to 2014 and then up 2014 to 2015 and down from 2015 to the present. So the whole ground rising and falling. Some people have characterized this like Yellowstone is breathing. If we go to the other side of the caldera, the west side near Old Faithful, we see the exact same pattern. It goes up in the early 2000s and then from 2009 to 2014 down and then up 2014 to 2015 and then down from 2015 to the present. So the caldera, again, rising and falling, and since 2015 it's been going down. Now, Norris Geyser Basin behaves differently than these other sites. You can see, and these are all on the same scale, so you can compare them all directly. Norris had a little bit of down in the early 2000s, didn't do much, had this little blip of uplift in 2013 to 2014, and then uplift from 2015 to 2018, and then it was pretty steady. But it was this bit of uplift that we were looking right at the very end. Maybe Norris is doing something a bit different. Well, it turns out it was responding to a seasonal change. And if we zoom in on these graphs, we can see exactly what that seasonal trend is. So this is the vertical deformation on that east side of the caldera station. See, it's down, and there's this little bit of sort of a pause in the downward motion or uplift, and then again, another one there, another one. Every summer, the caldera sort of bounces up a little bit. And that's caused by groundwater. So as the snowmelt percolates into the subsurface, it actually causes the ground to sort of expand like a sponge. And we saw that every summer at this site in the east side of the caldera. It turns out at Norris, we see the same thing. Here's summer of 2019 at Norris. There's a little bit of pause or uplift in the overall trends. Again here in 2020, just a little bit of change. And here again, it's more strongly expressed in 2021, but now Norris has started going down just like the caldera has started going down. So the changes we've been seeing at Norris over the last few months are seasonal in nature and not an overall trend. So Norris really isn't deforming all that much. Now this is just the last few years, right? But what's Yellowstone been doing over the long term? Now there we know by looking at past measurements, which go back to the 1920s, that there's a net rise in the ground. But it has been going up and down over time. But using geology, we can go back even farther. So here's a map of the north side of Yellowstone Lake, and you'll notice in this very detailed topography there are these little ridge lines. Now these are outlined with little dashed and dotted lines here, and the yellow arrows point to some of those. And here's a picture of what that looks like on the ground. There's one little terrace here, there's a bit of a rise, and then a terrace beyond that. Those terraces are caused by changes in the level of Yellowstone Lake, which is controlled by the outlet, the rise and fall of the outlet. So by looking at the terraces at Yellowstone Lake, we can understand what's been happening at Yellowstone deformation-wise, going back to the last ice age, 15,000 years ago. And when we do that, when we date these terraces, and we can date them based on the presence of ash layers, we can actually see ash from Crater Lake and Glacier Peak eruptions thousands of years ago on these terraces, and archaeological sites on the terraces help us understand their dates. When we date those terraces, we can see that over time, Yellowstone has gone up and down over thousands of years. But over the last 15,000 years or so, the net motion at Yellowstone has been down. And in fact, Yellowstone has subsided, deflated, by over 100 feet at the core of the caldera. So ups and downs at Yellowstone, that's part of what this caldera does. That's Yellowstone being Yellowstone. And frankly, it would be kind of strange if it weren't going up and down. That's just how Yellowstone behaves. All right, now let's talk about what happened during the last month in terms of deformation, seismic, and geyser activity in Yellowstone.
November saw relatively few earthquakes in the Yellowstone region. The University of Utah seismograph stations, which is responsible for the operation and maintenance of the Yellowstone seismic network, recorded just 137 events during the month. The largest was actually south of the park, just south of the south entrance and north of Jackson Lake. That was a magnitude 2.5 that occurred on November 10th. The largest swarm of the month was about 60 earthquakes occurred late in November just to the north of Old Faithful. So pretty average month in terms of seismicity in the Yellowstone region. Deformation trends have continued as they have since 2015. This is from the White Lake GPS station, vertical deformation, on the east side of the caldera, the Sour Creek Resurgent Dome. Each one of these dots is 1 day of data. Downward trends indicate subsidence, and upward trends indicate uplift. And over this 2-year period, and indeed since 2015, we've seen overall subsidence with these little summer pauses or episodes of slight uplift. And those little summertime episodes are caused by groundwater recharge. As all that water from snowmelt percolates into the subsurface slowly, the ground soaks it up like a sponge, and we see pauses in that subsidence or even a little bit of uplift. The same pattern is seen on the west side of the caldera and the Mallard Lake Resurgent Dome. This is from a GPS site near Old Faithful. There's that overall subsidence with a little bit of summertime uplift, or at least a pause in that subsidence. Now, you might remember last month we talked about potential uplift at Norris Geyser Basin. Now, there hasn't been a whole lot of deformation that we've seen there, but then there's this slight 1 to 1.5 centimeter upwarp during the summer, and it really wasn't clear whether this was real uplift or some seasonal pattern like we see in the caldera. Well, now you can see over the last month that has turned around, and so this is almost certainly, just like we're seeing in the caldera, one of these seasonal signals, basically the ground charging up with groundwater due to snowmelt. And if we compare the signal that we get at Norris to what we see in the caldera, you can see that the time period at which the uplift at Norris turns around matches pretty well with when we start seeing subsidence resume in the caldera. So that Norris uplift that we were looking at over the course of the summer, that very slight upwarping there, appears related to seasonal groundwater recharge and is not an overall uplift signal in the Norris area. So deformation in the Yellowstone region remains very slight, nothing really significant at Norris, and the caldera system remains in a period of subsidence as it has since 2015. And then finally turns to everyone's favorite geyser, Steamboat, tallest geyser in the world in Norris Geyser Basin. It remains active. Here is the temperature plot from the runoff channel of Steamboat. You can see all these little minor eruptive activity. It culminates in a major eruption and then a drop in temperature. This first eruption of the month occurred on November 12th, and then there was a second eruption that occurred very late on November 24th. And it's looking like we may be ramping into perhaps another period of eruptive activity. So Steamboat remains active, although not erupting quite as frequently as it has in previous years.
Well, that does it for the December 1st update. Now remember, if you have any questions at all, you can feel free to email us anytime. Our address is yvowebteam, all one word, at usgs.gov. Thanks for joining us, and until next month, stay safe and stay healthy. See you later.